Hey, hello friends, welcome back to the channel. This is Aili Bhattacharya, your stats buddy, and we are diving today into something super interesting. Okay, like we are going to talk about factorial moments and also knock out two very important properties of variance that are going to be our best friends in exams. Okay, so it sounds good, so let's get started. Let us start with our first slide. See here. What is this x factorial r? X factorial r, which everybody keeps talking about. Like, see, this is not x to the power r, okay? See this notation, it is x factorial r. It's also called the falling factorial or the factorial moment. See, how do we write it? We write it as x into x minus 1 into x minus 2 into goes on till x minus r plus 1. So that is the last term, x minus r plus 1. Now let us break it down term by term because I know notation can be scary. But trust me, it's just pattern recognition. Look at here. Look at the first term. What is the first term? First term is x. Second term is x minus 1. Third term is x minus 2. Then what will be the fourth term? It will be x minus 3. Then what will be the rth term? Rth term here it is written as x minus r minus 1. So did you see that? Did you see that the number we subtract is always one less than the term number? Like see, for the first term, which is the term number 1, what are we subtracting? 0. If you're talking about the second term, which is the second term, then we are subtracting 1. For the third term, we are subtracting 2. For the fourth term, we are subtracting 3. So basically, for the rth term, what will you subtract? It will you will subtract r minus 1. Now see, x minus r minus 1, what will be the value? It will be x minus r plus 1, and that is what it is written here, x minus r plus 1. That is why we stop at x minus r plus 1. But wait, how is this related to regular factorial? That is a very good question. Now, see, you already know what is a factorial, x factorial. It will be x into x minus 1 into x minus 2, and it will go on till 3 into 2 into 1, right? Now, notice the following factorial, x factorial r, is just, see, is just the first r numbers, right? First terms of x factorial. And what is this part? This part is basically x minus r factorial, right? Then we can write x factorial r is equals to x factorial divided by x minus r factorial. That is the connection of regular factorial with factorial r. Okay. Now coming to the next slide. In the next slide, we will prove the variance property. The first property was what? Variance of a plus x is equals to variance of x. Now let us start with the logic. Expectation of a constant is the constant itself. So here see, expectation of a plus x is equals to expectation of a plus expectation of x. And what is the expectation of a? It will be the constant itself. So it will be a plus expectation of x. Now look at the variance formula. Variance of a plus x is equals to what? Expectation of x minus expectation of x is whole squared, right? And here what is written instead of x? It is written a plus x. So we substitute the values like that. So expectation of a plus x minus expectation of a plus x whole squared. Now substitute the expectation we just found. What we found of expectation of a plus x, it is a plus expectation of x, right? So basically we get what? Expectation of a plus x minus x minus a plus expectation of x whole square. And if you just take out the, if you open the bracket, then what do we get? A plus x minus a minus expectation of x, right? And we can cancel the a's, right? So we get what? Expectation of x minus expectation of x is whole squared. So basically that is what? That is variance of x. So yeah, adding a constant doesn't change the variance. Okay, makes sense, right? Constant doesn't add any spread. All right. Now, coming to the next property. See the next property here. What was the next property of variance? It is variance of ax is equals to a square variance of x. Again, let us start with the expectation logic. What was the expectation logic of expectation of ax? It will be what? A into expectation of x, the constant will come outside. Now let us come to the variance part. Look at the variance. Variance of ax is equals to expectation of ax minus expectation of ax's whole square, right? Then as we have just found expectation of ax, what will be the result? It will be a into expectation of x. So we just substitute that in place of expectation of ax. Then what do we get? We get expectation of ax minus a into expectation of x's whole square. Now see, if we factor out the a, we take the a as common, then what do we get? Expectation of a into x minus expectation of x whole square. Now if we square it out, then what do we get? Expectation of a square into x minus expectation of x is whole square, right? And then since a square is a constant, we can pull it out too. So we get what? A square into expectation of x minus expectation of x is whole square, which is equals to a square into variance of x, right? And it is done. Like scaling a random variable scales its variance by the square of the factor. Okay? By the square of the factor. Now let us talk about the next page, which is the rth factorial moment. Yes, rth order factorial moment. From earlier classes, we already know what is the raw moments formula. It is 1 by n summation of xi to the power r. And what is the central moments formula? It is 1 by n summation of xi minus x bar to the power r. Right? Now we define the rth factorial moment as mu dash to the mu dash r is equals to expectation of x factorial r, which is equals to what is the value for expectation? What is the result? It is summation of x to the power r, x to the factorial r dot fx. Fx is what? The function, and this is x factorial r is what? The value. Okay. Now for binomial, we substitute the PMF as what? See here. For binomial, what is the fx or the PMF? It is n chooses x, p to the power x, q to the power n minus x, right? Now, if you replace the values of x factorial r, it will be what? X factorial divided by x minus r factorial. And what is the formula for n chooses x? It is n factorial divided by x factorial into n minus x factorial. And then comes the p to the power x dot q to the power n minus x. Now see, here we can cancel the x factorial, right, from the numerator and the denominator. Then what are we left with? We are left with n factorial divided by x minus r factorial into n minus x factorial, right? But here you need to change the limit. The limit should be changed to x equals to r. Okay, because if here x equals to, it will be 0, minus r is not, it does not exist, right? Minus r factorial will not exist. So we'll change the limit to x equals to 0 to r. Okay. Now see the next step. The next step is we will factor out p to the power r, because we are taking r number of p's outside, okay, from x number of p's. Then what are we left with? P to the power r summation, and we write the n factorial in its form. See, n into n minus 1 into n minus 2, and it goes until n minus r plus 1 into n minus r factorial, as we have already known, right? So next step is what? We are taking out n factorial r and p to the power r. Then what are we left with? Summation of n minus r factorial divided by x minus r factorial into n minus x factorial dot p to the power x minus r dot q to the power n minus x. Okay. Now see the next step. Now this all comes to the binomial form to p plus q to the power n minus r. Now what is p plus q? P plus q is equals to 1, right? And 1 to the power n minus r will be 1. So it will scale down to n factorial r dot p to the power r. Okay. Now see, we have got this. Now we will use this thing. We will use this thing to find the mean and variance of the binomial. Okay. Now see, we are given with expectation of x factorial 1. And what is x factorial 1? It will be expectation of x, right? And what is expectation of x? That is the mean. So we are given with the mean. See, n factorial 1 is what? N dot p, which is equals to np. So the mean of binomial will be np. Okay. Now see, what is expectation of x factorial 2, which is basically n factorial 2 dot p square, right? From the formula here, n factorial 2 dot p square, which is equals to n into n minus 1 into p square, is equals to n square minus n dot p square. And if you simplify it further, we get what? N square p square minus np square. Okay. And here you need to find this thing, expectation of x square, which is the variance. Okay. Now see, if you rewrite x square as x into x minus 1 plus x, then we can, if you see the expectation from both side. Like add the expectation here in the left hand side, expectation of x square and is equals to expectation of x into x minus 1 plus x will be what? Expectation of x into x minus 1 plus expectation of x. Okay, now what is expectation of x into x minus 1? What is this? N square p square minus np square, and expectation of x is what? Np. So we get this. Okay, now you need to find the variance of x. Expect, now we have got the expectation of x square, we know expectation of x, and we also know what is the formula for variance of x. Okay, if what is the formula for variance of x? The other formula, which is expectation of x square minus expectation of x is whole squared. Okay, so what do you get? N square p square minus np square plus np minus expectation of x is whole squared, which is np whole squared. Okay, and we get np into 1 minus p. And what is 1 minus p? It is q, right? And that is the famous result that the mean of binomial will be np and the variance will be npq. Okay, so basically, that's a wrap for today. We covered what are the things we covered. We covered what factorial moment means, two key variance properties, how to derive binomial mean and variance using the factorial moments. And in the next session, we will solve some problems based on these concepts. Okay, so stay tuned. Until then, take care, have a great day, and don't forget to check out the notes I've already uploaded in the description box. I have put all the pages in one post on my blogger account, so you can grab everything in one go. Okay, so yes, happy studying, and I'll see you in the next video. Bye bye. Thank you for watching.